Hi there, Mr. Sutton, bringing you the AB Calculus 3-4 extra practice solutions on graphing derivatives. For this problem, we're trying to match this graph with its derivative over here. So I noticed that my slopes here are starting positive, becoming 0 as I get this smooth turnaround, and then becoming negative. So I want to look for a y prime that starts above the x-axis, crosses the x-axis around the origin here, and then goes into negative territory. So that out of all of these, that's going to be answer choice B. On this problem, I'm trying to match this function with its derivative over here. I notice that my slopes are starting positive, turning to 0 at this plateau here, and then continuing to be positive. So I need a function that starts above the x-axis and remains above the x-axis and crosses only once. So that would be this parabola here in choice A. On this one, we're trying to figure out which of these derivatives matches this original graph. So I see here that I have all these different smooth turnarounds, and this looks to be a cyclical function. Like this looks like it could be a cosine function that just keeps changing. So really, I mean, I'm crossing, my derivative is crossing the x-axis in a bunch of places. But how does that narrow it down between choices C and D? Well, C looks like we're crossing 3 times and then veering off to infinity for the derivative, whereas D, it looks like we keep crossing over and over again forever. So if I'm looking for a slope that keeps changing signs at regular intervals, I'm definitely leaning towards choice D for this, since this is actually cyclical. Trying to match this function with its derivative, I notice that my slope is starting off very negative, and then we're turning around, so we've got a negative 0, positive 0, negative 0, positive, and then it ends very positive. So the graph that goes a bunch of times and starts very negative and ends very positive, that would be choice C. For this problem, I'm trying to match this graph with one of these derivatives down here. So I notice that this is differentiable everywhere. This is a polynomial. So that definitely means we're not doing choice D. And then in terms of my slopes, it looks like we're going negative, 0, and then we're going positive, 0 again, and then negative. So which slope starts below the x-axis, goes positive, and then becomes negative again? Well, that looks like choice B. We're starting negative, going positive, going negative again. So let's pick that one. Trying to match this graph with a derivative down here, I notice that I have a constant positive slope. I have this corner. I've actually got 2 corners here. So these are places that will be non-differentiable in the derivative. So these are going to be like jumps if I go to my derivative. So I'm starting out positive, then negative, then a positive. And these are constant slopes here. So that's going to match answer choice D, where we have a bunch of horizontal lines representing those constant derivatives. On this graph, trying to match this with one of its derivatives down there, I notice that my slope is close to 0 and then becomes 0 after we get a little bit negative. And then as the original increases, our slope becomes positive and then goes close to 0 again. So this is differentiable everywhere, and slightly negative, 0, slightly positive. So that's in terms of the what the derivative should look like. So this choice here, answer choice A, notice that we're slightly negative, become more negative, then become 0, then positive, then slightly positive. So we're picking choice A. To match this function with its derivative, we notice first this is differentiable everywhere. So that means choice D is not going to be it. In terms of our slopes, the original's increasing, so f prime is going to be positive. Then we become 0 at the smooth turnaround, negative, 0, positive slope, 0 again, and then negative. So there was the order of what our slope should be doing. So starting off, let's look at one that starts out positive. Well, that would be choice C. These other ones start out negative. And then, let's see, we go to 0 and negative, and then we're 0 again, positive, 0 again, negative. Yep, choice C. For this problem, we're trying to sketch the derivative for this graph. Now this one has a whole bunch of corners, which means you're going to be jumping around all over the place with a bunch of constant slopes for your derivatives. So we're going to be alternating constant negative and positive derivatives, and we're going to have these open dots for our jumps at the corners since we're not differentiable at the corners. So this first one, since we have a negative slope, we're going to have a negative constant function down here to represent that with a derivative. And then we jump to a positive slope, so we'll have a positive constant function up here. And then we're going negative, positive, negative, positive, and then it just keeps going back and forth here. Just keep switching. And that's what our derivative should look like. To graph the derivative for this function, I'm going to start with critical values. I notice that I have an asymptote here on the original. That always gives me an asymptote on the derivative as well. Another asymptote over here at x equals 4. And then I notice I have this smooth turnaround right here at about the origin for the original. So that's going to be an x-intercept, a derivative of 0 for f prime. Now let me do a little sign analysis on this for f prime. The original's increasing before this asymptote, so f prime is positive there. Original's still increasing until we get to this x-intercept. So that's going to be, or until we get to the smooth turnaround in the original. So that's going to be positive derivative. Then notice that we're decreasing on the original, so negative f prime, and then still decreasing up here on the other side of the asymptote, so still a negative f prime. So my f prime needs to start positive and approach this asymptote. So the only way to do that is if we do one of these kind of deals, like so. And then next we are going from positive to negative and approaching the asymptotes. So we're going to start up here, come through this x-intercept, and go down here like so. And then finally we are negative and staying negative, so we have to start down here and approach the x-axis like so. And there's our derivative. To graph the derivative of this one, let's do critical values first. The original graph f has a smooth turnaround right here at about x equals negative 1. So that gives us an x-intercept for the derivative. And then doing a little sign analysis, I notice the original is decreasing, so f prime is negative until that smooth turnaround. And then afterwards, the original's increasing, so positive f prime. So f prime then is starting below the x-axis, crossing right here, and then going above the x-axis in a linear fashion like so. To graph the derivative for this function, let's start by finding critical values. We have a plateau right about here. It's kind of hard to tell if this is multiple smooth turnarounds or one plateau. I'm going to call it one plateau. So that's an x-intercept for the derivative right there. And then before then, the original function is decreasing, so f prime is going to be negative up until that spot. Afterwards, the original continues to decrease, so f prime is still negative. So we're starting below the x-axis, hitting this point, and then coming back below the x-axis again in a parabolic-like fashion. On this problem, we're trying to graph the derivative of this function. This is one that's so easy it's hard. This is a constant original function. The slope is always 0, so that means the derivative is also going to be a horizontal line on the x-axis. To graph the derivative for this function, let me start with critical values. So I have a smooth turnaround right here at about negative 4. That means f prime has an x-intercept there. Another smooth turnaround at positive 4, or thereabouts. So another x-intercept for f prime. Doing a little f prime sign analysis now. The function is originally decreasing, so f prime is negative. Function is then increasing, so positive f prime. And then we're decreasing again for the original, so f prime is negative. When I graph this out then, f prime starts below the x-axis, hits right here, comes above, hits again here, and comes below. So we basically have a big parabola going through those. To find the derivative of this graph, we'll start with some critical values. I notice the original has a vertical asymptote here at x equals 2. So the derivative will also have a vertical asymptote there. And I notice we've got some smooth turnarounds at about the origin and around, let's see, this looks like a little bit more than x equals 3. So the derivative is going to have x-intercepts at about those spots. So one right here, and another right about here. There we go. There we go. Let's make those a little bit more on the x-axis there. Now doing a little f-prime sign analysis, we're going positive right here for f-prime because the original's increasing. Then the original's decreasing, so negative f-prime. Still decreasing until this turnaround, so still negative f-prime. After that, we're positive f-prime again. So f-prime is going to start above the x-axis, hit right here, and then become negative. So something like this. And then we're starting negative, so very negative actually, because this is a very steep downslope. Then we go through the x-axis and become positive, so maybe something symmetrical looking like this. And that'll do it.
For this problem, we're given the graph of f of x up here on the interval from 0 to 5. We want to know which of these down here could be the graph of f prime. So one thing we notice is that we have, we have a max at 2, we have a min at 3, we have turnarounds there. So that at the very least, since we have local extrema at 2 and 3, we're going to be changing around. We're going to be changing the sign of f prime at those two x values. So let's look for a graph that changes sign twice at 2 and 3. Graph A, we're changing from positive to negative at 2 and from negative to positive at 3. So far, choice A is looking good. Choice B, we change sign at 3 but not at 2. So we can eliminate B because it doesn't have that sign change that we need at x equals 2. Down here, choice C changes sign at 3, but again, not at 2, so C is gone. And then choice D, we're not really changing sign at 2. Yeah, we kind of are. Yeah, I guess so. We'll count it. So we're changing sign at 2, but at 3, we're not changing sign. So it looks like only choice A actually meets this condition. Now, if you take a look at the particulars here, we're going from a slope that's positive and then jumping to a negative slope, which is exactly what's happening with the derivative in option A. And here, we're changing from a negative slope to a positive slope. And notice down here in the graph of A, we're changing negative to positive with that derivative. So everything is adding up here to choice A.